Every enterprise supply chain planner operates within a strict mathematical paradox. On one side, there is the mandate to maximize product availability so a customer can always buy what they want. On the other side, there is the mandate of finance: minimize the sheer volume of cash tied up in warehouse aisles. We measure availability through customer service level, or CSL. This metric tracks the percentage of demand fulfilled on time and in full from available stock. When CSL is high, operations run smoothly and revenue is captured. The opposing force is measured by inventory turns, or ITO. This calculates how many times inventory is sold and replaced over a given period. High inventory turns indicate tight capital efficiency. The company is not paying to store stagnant boxes. Balancing maximum CSL with maximum ITO across a portfolio of 10 items is difficult. Across thousands of highly variable SKUs, relying on manual calculation is mathematically impossible. The permutations outpace human processing speed. This split-screen graphic illustrates two catastrophic failure states. Prioritize capital efficiency too heavily, and you hit a 0% CSL fulfillment failure, stopping production lines entirely. Prioritize availability too heavily, and working capital inflates, drained by slow-moving and obsolete inventory. Escaping this paradox requires a specific approach. Modern enterprise planning relies less on manual forecasting and heavily on encoding strict strategic business rules into the master planning engines of systems like Microsoft D365 and SAP. Supply chain mastery requires the translation of physical product life cycles into dynamic, automated ERP rule sets. To build these rule sets, we must account for the first major variable in inventory architecture: the predictability and volume of demand. A high-volume standardized component requires a completely different digital framework than a low-volume bespoke item. For predictable items, planners deploy a make-to-stock, or MTS, strategy. Take the Keller and Kalmbach supply chain managing Siemens' standard fastener range. Because thousands of these identical fasteners are consumed weekly, inventory is procured in advance based on a forecast. This simulated line graph tracks an MTS strategy in action. Inventory draws down over time until it hits this predetermined floor, known as safety stock. The moment it drops to this level, the ERP system generates an automatic purchase requisition to bring the stock back to the maximum threshold. The planner rarely touches it. By expanding this matrix, the right side now maps the make-to-order, or MTO framework. For custom, high-cost components built for Bentley Motors, the logic shifts entirely. The system is instructed to ignore forecasts. Procurement is only triggered by a confirmed customer order. Notice the x-axis baseline on the Bentley side. It stays pinned at 0 until demand arrives. Because these items are highly customized and expensive, holding them speculatively would immediately create obsolescence risk. Planners dictate these behaviors directly within Microsoft D365 by configuring the item coverage group. Setting the coverage code to min-max activates the automated Siemens strategy. Changing that code to requirement enforces the strict zero inventory Bentley rule. Misaligning these parameters, applying an MTS forecast to a bespoke item, or forcing MTO rules onto a fast-moving commodity results in severe operational failure. Standardizing these algorithms at the item level dictates exactly how corporate cash is deployed. Industrial hardware provides a stable baseline for algorithmic rules. However, edge case environments require intense operational intervention when those algorithms encounter real-world friction. Consider the medical supply chain, Johnson & Johnson surgical assets. In active surgical environments, an inventory stockout is a severe medical emergency. The standard goal of high availability is replaced by an absolute mandate, a 100% customer service level, zero tolerance for delay. Here we see a standard Power BI dashboard UI, utilizing red, amber, green, or RAG logic. Master planning engines calculate delivery dates based on standard supplier lead times. If a supplier delays production, the shipment block moving along this timeline falls behind. The row flashes red because the physical supply will not arrive before the inventory drops through the safety stock floor. When the system flags an imminent failure, planners execute a manual intervention, known as expediting. This requires overriding standard ERP transit parameters and spending capital to accelerate the physical movement of goods. Defending a critical inventory floor often means upgrading a delayed ocean freight container to premium air freight. It is a highly expensive lever, requiring immediate leadership approval, but it effectively buys back the lead time the supplier lost. The frequency of these costly interventions is dictated by on-time in full, or OTIF. This KPI tracks the exact percentage of supplier deliveries that arrive by the promised date and in the exact quantity ordered. Enterprise software operates on the assumption that suppliers execute perfectly. When they do not, the planner must analyze the data, quantify the risk, and manually override the algorithm to protect human critical stakes. We can scale this logic further by applying it to the high-complexity environments of fast-moving consumer goods and footwear. At brands like New Balance, managing supply requires mapping parameters to a volatile commercial timeline. In footwear, a single shoe design does not represent a single inventory item. D365 requires product dimensions, style, color, and size. A single running shoe model easily fractures into 30 or 40 distinct SKUs, each requiring individual master planning coverage parameters. This bell curve maps product sales volume over time, introducing the rule that an item's algorithmic parameters cannot remain static. They must mutate as the product transitions through beginning of life, middle of life, and end of life phases. Zooming in on the beginning of life phase, historical data does not exist. Planners use allocated programs, distributing initial inventory based on comparable launches. This overlaid bar chart visualizes a size curve, dictating the exact ratio of core sizes to extreme sizes, ensuring the initial system buy aligns with expected human dimensions. Moving to the peak middle of life phase, demand stabilizes. Here, the diagram displays an advanced AI planning layer, like O9 solutions, building the aggregate forecast and pushing it directly into the D365 master planning engine. D365 then handles the execution, outputting a steady cycle of min-max replenishments. Eventually, every product enters its end-of-life phase. At this exact moment, planners must manually intervene in the ERP system to halt the automated replenishment algorithms. The objective switches entirely to forcing sell-through of the remaining stock. The master planning engine is completely blind to marketing calendars. It only executes the mathematical instructions it holds. Failing to update an item's coverage parameters as it exits its peak phase guarantees you will buy product that no one will purchase. When that transition fails, the result is the rapid accumulation of slow-moving and obsolete inventory, universally referred to as slob. This is dead capital taking up physical warehouse racks. The financial impact of poor parameterization is severe, but it is also reversible. During a major supply chain initiative at Flint Group, planners isolated the impact of misaligned lifecycle coverage. By extracting the velocity data from SAP, the planning team categorized the dormant stock into strict tiers: items to consume, items to push via sell-through discounts, and items requiring immediate write-off. Executing this specific end-of-life strategy directly recovered £300,000 in tied-up working capital. This recovery effort is driven by continuous improvement. Supply chain professionals utilize structured methodologies like Six Sigma and the DMAIC framework, define, measure, analyze, improve, control, to systematically hunt down these inefficiencies and rewrite the operational rules to prevent them from recurring. This flowchart shows the complete picture. O9 forecasts and D365 master planning logic feed data into a Power BI RAG tracker. When lead times or OTIF drop, the tracker isolates risk. Categorizing life cycles and halting end-of-life buys recovers working capital. Enterprise planning requires an exact mathematical understanding of system rules, but executing those rules successfully relies on the relentless, data-driven alignment of physical market realities with the architecture of the system itself.